reached the end of our review. 18 questions. In the beginning, I thought I was doing Module C, but I'm doing the final exam review, so let's stick with that. Here's question 18. Let's get it set up with some writing tools. Here we go. At the beginning of a study, a certain culture of bacteria has a population of 340. Population grows according to a continuous exponential. We use this a lot because in science it gets used a lot. This is growth, so our rate is going to be positive. It tells us after 6 days, so we've got the time, there are 544 bacteria. So we see that, okay, yeah, it's growing. So the first thing we have to do is remember the exponential equation, but we get some help here. So one of the things with taking a test is you might want to go through, if you couldn't remember this, there's something in front of the E, and then there's a thing here. Remember, that's just your PERT, P-E to the RT. And Y or A, you could put anything here. Remember, R is your rate, so we use R. T is for time. E is not a variable, it's a number. It's 2.71 something, something, something. And then P is our principal or our starting value. We'll just say, yeah, initial value. And Y is our ending value of whatever many days or time period we have. Value. Right? So we've got enough, we can come up with this, and then we've got another, once we're going to use this equation to come up with a calculation. Okay, so what do we have? We started with 340. Write that down. We know we're going to have E to the R, but they don't, what are we looking for? It grows according to conditional. Okay, so yeah, we're looking for the rate to come up with this formula. We don't have that, but we do have the time. Wait a minute, what do we have? Yeah, we don't have the rate, but we have a values, right? We've got that in 6 days. We will end up with 544. That's what we're going to use. So we have 6 days. So that's all up in the exponent that we would end up with 544. It's going to allow us to solve for R. We didn't really have to solve for the P because it was given to us, but we did have to know at the beginning, that's the start. That's number is going to be right there for the P. That gets multiplied by the E. So yeah, they just gave it to us. So let's go ahead and put that in there. Now we just need this as and we'll find it as a rate of 0.0 something. Remember, it's an interest rate, or it's interest. So it's a percentage is what we're going to be finding. Okay, so how do we go about this? Kind of like, again, we'll do the log dance actually to solve it. But before we can do that, we have to isolate the exponential. 340, 340. So we get E to the R times 0.6 is equal to they want us to use exact expressions to fill in the missing parts of the formula. We do not use approximations. Let's divide this and see what we get. If it's a non-repeating decimal or something, then we can't use it. If it's a terminating decimal, we could use it, but let's see, 544 divided by 340. I have a feeling, 1.6. We could use that. That's an exact value. The thing that isn't an exact value is something like the one above it, where we just keep getting a lot of decimal places. You just get too many that don't never seem to stop. That's not an exact value. That's a rounded value. Okay, this 1.6, we could do that. Then we do the log dance, right? Or you take the natural log of both sides, however you want to do it. The log dance says that we're looking that we've got two things. We could look at this as 6R if you wanted, but we're going to have a log base E, which is going to be ln, and these the e and the exponent are together, so they have to be on opposite sides of the equal sign. I'm going to write that as 6r. R6, either way works. And the 1.6 goes here. And remember, that's a natural log. So I'm going to rewrite that as a natural log, but let me divide both sides by 6 first. And so we're going to get that the rate is equal to the natural log of 1.6 divided by 6. Now, we could have had the natural log of 544 over 340, right? Especially if it didn't come out to a nice number. But this should work. This should work. So what's the value for r? They want the exact value. I use this one. Let's do this one first. And then the natural log of 1.6 divided by 6. Erase that stuff. Okay, so that should be it. Then the next step for the second part is how much would be left after 9 days. Well, since it's increasing, 6 days is 544, we would expect a larger value, 3 more days, right? But we can just calculate this from our equation here. What we're going to use is 340e. We'll just use it as is. Natural log of 1.6 over 6 times 9. And we just have to enter this into our calculator and we will get our answer. So 340 times it, and yeah, I'll put a times. E raised to the natural log of 1.6. Close that. Divided by 6. And then I'll put a parentheses around this one. Now, to sneak a parenthesis in here, there's this INS. So I'm going to go second INS is insert. There we go. We inserted it. So that's all together. And then I want to be up here. I've got to get back up into the exponent. And I want to multiply this by 9. Just make sure you're up there. And maybe put another set of parentheses, however you want to do it. But practice with these. And if you can get it right here, then you should be able to get the formatting right. But we have a way of checking, because 688, yeah, that makes sense. 544, we're going to have more. It seems reasonable, doesn't it? Do not round any intermediate. Round your answer to the nearest whole number. So we just put in 688, which makes sense. You can't really have half of a bacteria. At least I don't think you can. I'm not a biologist, but probably makes sense. Okay, so that's number 18. And that's how we can do that one.